Good morning. Today we will study about Nernst heat theorem and the third law of thermodynamics. Nernst was awarded Nobel Prize in the year 1920 for this Nernst heat theorem for working on thermochemistry. He is a German chemist. Okay. Now let us see how he derived the Nernst heat theorem. How he obtained the Nernst heat theorem. It is very, very important. We know that the change in free energy is equal to minus N of E. We have studied in electrochemistry. Okay. So delta G is the decrease in free energy minus and N is the number of electrons involved in the electrochemical process, electrochemical reaction, and F is the number of Faraday of electricity passed, and E is the EMF of the cell produced. Okay. So on differentiating equation 1 with respect to temperature, let us differentiate this delta G with respect to temperature. The variation of free energy change with respect to temperature equal to minus NF. The variation of EMF with respect to temperature. Okay. According to Gibbs-Helmholtz equation, also we know from Gibbs-Helmholtz equation, delta G minus delta H equal to T dou delta G by dou T at constant pressure. Okay. This is also obtained from the second law of thermodynamics. I have shown here. Please watch, see that. Okay. And Richards measured the EMF of the cell. Richards measured the EMF of the cell at different temperature. He measured the EMF of the electrochemical cell at different temperature, and he found that the EMF of the cell is decreasing. So this is decreasing means dou delta G by dou Tp also decreasing. So Richards measured the EMF of the electrochemical cell at different temperature, observed that this is decreasing, therefore dou delta G by dou Tp also decreases with the decrease in temperature. Okay. So if this is decreasing, the difference between delta G and delta H also decreasing. Remember, this is decreasing with the decrease in temperature. Therefore, delta G minus delta H also decreasing. This is shown graphically. In y-axis, temperature is shown, and in x-axis temperature in Kelvin, y-axis delta G, delta H, and this is absolute 0 Kelvin. Okay. Now you see at high temperature, delta G minus delta H is appreciable with the decrease in temperature. This is decreasing, therefore this is decreasing, therefore it is approaching towards 0. Okay. He concluded that delta G and delta H approaches each other. The difference is less means delta G is close to delta H. So he concluded that delta G and delta H approaches close each other. Okay. With the decrease in temperature. Based on the above, Nernst made a generalization. Nernst proposed that the value of dou delta G by dou T approaches 0. Dou delta G by approaches 0 because with the decrease in temperature, EMF of the cell decreases. Gradually decreasing the temperature to absolute 0 Kelvin, called Nernst heat theorem. Okay. It is applicable to only pure solids. Okay. Mathematically, now this is the generalization of Nernst heat theorem. Okay. Now let us see the mathematical form of Nernst heat theorem. Limit T tends to 0. When T approaches 0 Kelvin, then dou delta G by dou T at constant pressure is also equal to 0 at temperature. As it approaches absolute 0 Kelvin, this is also equal to 0. This is the mathematical form of. Similarly, this equal to this. Therefore, limit T tends to 0, dou delta H by dou T at constant pressure is also equal to 0. Okay. Okay. Now, these are the mathematical form of Nernst heat theorem. Okay. They are derived from the above. Okay, we know from second law of thermodynamics. I have shown here on the right hand side of the board. Dou delta G by dou Tp equal to minus delta S. Okay. Therefore, similarly, from Kirchhoff's equation, dou delta H by dou T equal to Cp. From the definition of molar heat capacity you are studying. Okay, the difference in heat capacity of delta Cp is the difference in heat capacity of products and reactants. Therefore, on substituting here, that limit T tends to 0, delta S equal to 0, and the limit T tends to 0, dou delta H, delta Cp equal to 0. Okay. Based on the above, Nernst heat theorem, the third law of thermodynamics was enunciated, formulated. Okay. Max Planck also showed that, using quantum theory, he found that the heat capacity of the pure solid at absolute 0 Kelvin is 0. Okay, he calculated using the quantum theory, Max Planck, and he found that for the pure solid at absolute 0 Kelvin, the heat capacity is 0. That is, limit T tends to 0, heat capacity equal to 0. Okay, heat capacity. Therefore, and also he made a generalization that since this is equal to 0, then yes, limit T tends to 0. Yes, also the entropy of the substance, pure crystalline substance is also approaching 0 at when T tends to 0, S equal to 0. Okay, this is the mathematical form of third law of thermodynamics. Now let us see the statement of third law of thermodynamics at the absolute 0 temperature Kelvin, the entropy of every substance may become 0, and especially in perfectly crystalline solid it becomes 0. Okay. Entropy of every substance may become 0, and in perfectly crystalline solid it becomes 0, because in perfectly crystalline solid all the molecules are perfectly in order, all the molecules are oriented in perfectly in definite order, and the entropy, therefore the entropy is 0. Therefore limit T tends to 0, S equal to 0, limit T tends to 0, Cp equal to 0. Okay. Now, what is delta Cp? Delta Cp is the heat capacity of products minus heat capacity of the difference between the heat capacity of products and the heat capacity of reactants. At absolute 0, remember, the difference in heat capacity is equal to 0 because Cp of pure crystalline substance is equal to 0. This is equal to 0, therefore the difference is equal to 0. At T equal to 0 Kelvin, the Cp and the entropy, molar heat capacity at constant pressure, and the entropy of reactants and products are equal, because the difference is delta Cp equal to 0 means the heat capacity of product equal to heat capacity of reactant. They are equal. At absolute 0, the heat capacity is equal to 0. Okay. So this is the statement of third law of thermodynamics. This is very, very important. So many questions are asked based on Nernst heat theorem. Okay. So please study well. Thank you for watching.